How does Coolnomix work? Coolnomix is a British-designed control technology for vapour compression cooling systems. It's a retrofit energy efficiency device that reduces your cooling system's energy use, carbon emissions, and improves temperature control. It works by controlling when cooling is turned on and off. Coolnomix uses a small control unit, 2 precision sensors and an electric relay. The 2 sensors are placed in the supply and returned airflows and provide feedback to the control unit. The control unit sends signals to the cooling equipment to let it know the optimal time to run, in order to minimise energy consumption without affecting the output you need. To understand how Coolnomix works, imagine a vapour compression cooling system with indoor and outdoor units. The compressor is used to compress the refrigerant from a low-pressure saturated vapour to a high-pressure state. Next, the refrigerant is circulated through a condenser, where heat is removed from the system and dissipated to the surrounding environment. Then, the refrigerant flows through the expansion valve, causing a drop in the temperature and pressure. At the evaporator, heat is absorbed from the returned airflow, providing cooling for your space. The refrigerant then returns to the compressor, completing the cycle. The thermostat is generally used to control when the compressor is turned on and off. The compressor consumes most of the energy in your cooling system and runs longer than necessary. When this happens, the condenser cannot dissipate all the cooling load provided by the compressor and excess energy is consumed. Coolnomix solves this problem by using a software algorithm we call Optimized Refrigerant Supply. It uses sensor readings and AI-based predictive analysis to determine when your space is being cooled to the target temperature and when the right amount of refrigerant has reached a high-pressure liquid state. This allows Coolnomix to cycle off the compressor at the optimal time, reducing overall energy consumption and significantly reducing your carbon emissions.
During the installation of each Coolnomix, an installation control sheet must be completed. First step, record site and unit information. The second step is to perform a system health check and sizing check to deem the system suitability for Coolnomix. During the health check, we record using 3 temperature probes with min-max capability. We record return air temperature, cool space temperature, cold supply temperature. Calculate the delta T of the minimum return air temperature and the minimum cold supply temperature.
Okay, stage 3, we're looking to mount the Coolnomix system here. So mount the Coolnomix system next to the fuse spur, and on the Coolnomix unit we have 2 fixed points for placement, and then we have 2 connection points. On this side here we have our 240 volt connection and we have our relay connection. The red block here is your settings for your set point for your air conditioning unit, which we'll go into after. Connection point into the switch spur. That will be connecting to the outgoing of the switch spur. The relay connection will be brought through the box here to look neater. And what we're looking to do is connect this cable in series to the return air sensor on the PCB board. We're doing our connection points now for a 240 volt connection. So we have live and neutral. The Coolnomix system is no earth. So we'll be connecting our live and neutral into the outgoing of the fuse spur. That's a 240 volt connection done. We're now looking to identify our relay connection. The relay connection is coming from this part on the Coolnomix system. Cable's coming through, and we'll bring it up in around by the PCB board. What we've got to do is identify the return air sensor and find out which cable it is. So on this particular system, these are our two return air sensor wires. Because we're wiring in series to the return air sensor, we cut one of these wires. We've worked in these systems before, and we know that we use a 10k resistor. If this was a system that you wouldn't have installed on before, you would have to measure the resistance on the return air sensor. To ensure that it's an NTC resistor, you would hold the resistor in your hand, and if the resistance drops, then you know it's an NTC resistor. For this case, we're going to cut one of these legs and connect in series this cable. Cut one side of the return air sensor and install a Wagyu connector or any connector on either side of that connection point. Then you would install one leg to either side of the return air sensor to your relay cable also. So that's wired in series on one leg of the return air sensor only. Then plug back in the sensor. Onto the PCB board. Okay, that's your two connection points now completed. Your relay connection to your return air sensor and your 240 volt connection to your fuse spur. The next 2 points that we install now are replacement points. We have two of them, one white and one black. The black is always for your supply air, which is located on the front of the air conditioning unit. We will place that sensor anywhere in here, not next to metal or anything that can change the reading that it's trying to sense. The white connection is for your return air sensor. That gets placed in situ to the original return air sensor. With the two sensors, the white sensor here will be placed in situ with the return air sensor, and the black one will be placed in the supply air space. So what we're trying to do first, bring the black sensor through the air conditioning unit, cable tie it in freestanding into the supply air space, make sure it's not hitting any metal, as neatly as you can, bring it back through the unit and cable tie it where it's not going to affect the workings of any of the moving parts. Finally, what we're trying to do is bring the the supply air cable back through the unit, and any excess cable, what we'll do is coil it up and leave it in the unit. After we repeat the process with the return air sensor, you will cable tie them back up to one of the pipes up here. So this is your return air sensor. Will go in situ to the existing return air sensor. Feed your cable up following the same path as the existing ones and just back around. And again, when you're finished, just cable tie the two of them back together to keep any slack off. There's many different ways that you can lose the slack, and depending on the method of installation, you may lose it up in the roof. For this method, we're just leaving it in behind here, as it's a training system. So setting up the Coolnomix system, what we have to ensure is that the air conditioning unit is in cooling mode only. If it's in automatic or heating, Coolnomix will go into fail-safe and will not work. So this particular unit here is set at 21 degrees. What we're trying to do is set our set point on Coolnomix 2 degrees above this set point. So 23 degrees will be what we'll be setting Coolnomix to. Okay, what we're looking to do now is do the set point for the Coolnomix system. The remote control is set to 21 degrees and it's on cooling. So what we want to do is set Coolnomix to 23 degrees. If we look at the booklet, it ranges from 16 degrees up to 31. If we look at 23 degrees, we know that the first 3 toggles are up and the last one is down. So looking at this unit here now, to go to 23 degrees, you have to switch these 3 top toggles on. This one remains down, coinciding with the picture at 23 degrees. That will now lock in your set point at 23 degrees on your Coolnomix system. This can be later changed on the Connect app, which we'll install into the bottom 6-pin connector here and connect via our phone on an Android system. We can do that later on. From the measurement of our return air sensor, we were able to see that it was a 10k resistor. What we're going to do is put a 5.7k resistor into the Coolnomix system. This will mimic the resistance from the return air sensor back to our controller. This resistor could also be wired in the field, but for ease of install, because it's wired in series, we can connect it straight back into the controller. Following that, just replace the cover and cover up the Coolnomix system. There's 2 screws here which you lock it down in place. Okay. Commissioning the Coolnomix system, turn on the power of the AC unit and you'll see the green light flashing. This will flash for up to 3 minutes. What it's doing is it's holding off the compressor located outside and it's keeping it in safe mode. After this 3 minutes is up, this green light will go solid green, and when the Coolnomix system is required to hold off the compressor, the red light will start flashing. This is installing the Connect card for Coolnomix. This is for peer-to-peer Bluetooth connection and it goes onto the bottom pin section in the Coolnomix unit. It basically plugs straight on. As you can see, it pairs automatically once you plug it in, and now it gives you the ability to be able to connect to an app which we can provide. So through any Android device, you log on to the Coolnomix app and you press scan. It will start scanning and you can see that you have now seen the Coolnomix device. You press on it and you can see its ID code. It's connected and starting. At this moment in time you can see the green light flashing, which means that it's still trying to get the temperature in the room. So we go into the app here and we start logging. it will now start logging the data. Every 5 seconds it logs the data, and it shows you your cold air temperature, your return air temperature, and whether the relay is actually working. You have the ability on this app to also change your set points. So you can change the set point at any time. Let's say 21 degrees, and it changes it automatically. This is good for a service tool once the system is actually installed. You can also rename it for training room. And now you can identify underneath the sequence of what location that you're working in. This can be done across site. From this also, you can do a saves log. So I'm doing test run. So what we're actually doing here is resetting the Coolnomix system and making sure that it works. So final checks on the Coolnomix install. With these cables here, because it's for training only and they'll be removed for different people to install, we haven't concealed these in trunking, but usually you would use trunking at the side and up and into the unit to conceal all cables. Also, what we want to check is that our supply temperature and our return air temperature hasn't decreased as per your previous checks. It needs to be the same. So we're looking for a 10-degree differential from supply to return air, and when Coolnomix is installed, that will be the same again.